Okay, let's go over how factoring polynomials works, because we're going to need to do that in some of the things that are coming up, like some of the things we'll be doing with rational expressions or solving certain kinds of equations. So when you've got a polynomial that you want to factor, the first thing to look for is there a common factor you can factor out? If there is, you want to start by pulling out the greatest common factor. So a factor is something that a term is divisible by. You can write it as that thing times something else. A common factor would be when all of the terms have that same factor in common. And we want the greatest common factor of all the terms. In this example, 5x squared plus 15x minus 20, the greatest common factor is 5. All of these terms are divisible by 5. They all have 5 as a factor. They can all be written as 5 times something else. So we can take the 5 that they have in common, put that outside parentheses, and then put the something else's inside the parentheses. You would need 5 times x squared to get 5x squared. You would need 5 times 3x to get 15x. And you would need 5 times minus 4 to get minus 20. So we've factored out the 5, and whenever you factor something, you could always check to make sure it's factored correctly by multiplying it back out and seeing if you end up with what you started with. Now, sometimes after you've factored out a common factor, there's something else you can do. You can factor further. And that might be true here. We'll come back to this one later. Right now we're just focusing on common factors, but later on we'll see what else we can do with this. But what about this? What's the greatest common factor here? There's only 2 terms, and the numbers don't really have anything in common. But when you look at the variable parts, they do have something in common. They both have at least one x. The 8x has an x. The negative 13x cubed has an x times 2 more x's. So we can pull out an x. Write this as x times negative 13x squared plus 8. And now here's one where the greatest common factor is going to have a number part and a variable part. Can you see what both of those parts are? What's the biggest number that is a factor of 6 and 12 and 8? Well, the biggest number that works for all 3 of those would be 2. And what's the biggest power of x that's part of all 3 of these terms? That would be x to the 3rd power. These all have x to at least the 3rd power. Maybe just x to the 3rd power, maybe x to the 3rd power times 1 or 2 more x's after that. So the greatest common factor is 2x to the 3rd. So that's what goes outside the parentheses, and then inside we have whatever we have to multiply that by to get this. 2x to the 3rd times what gives you 6x to the 5th. Plus 2x to the 3rd times what gives you 12x to the 4th. And then 2x to the 3rd times what gives you minus 8x to the 3rd. Well, all of those whats turn out to be 2x to the 3rd times 3x squared plus 6x minus 4. So that is the correct factoring there. Now let's look at some special patterns that you need to watch out for. A difference of 2 squares. That's where you have one perfect square minus another. Like here we have x squared minus 49 would be 7 squared. So there's a special rule or pattern that you use in that kind of a situation. This factors into u plus v times u minus v. The u stands for the first thing that's being squared and the v is the second thing that's being squared. So here that would be x plus 7 times x minus 7. And if you wrote those in the other order, that would be fine. Same 2 things multiplied together, order doesn't matter. But one of them has to have a plus and one of them has to have a minus. So that when you multiply this together, x times x is x squared. The outside and the inside cancel each other out. Negative 7x plus positive 7x adds up to 0. And then the plus 7 times the minus 7 gives you the minus 49. What about 4w squared minus 81y squared? That's another difference of two squares. These are both perfect squares. What do you have to square to get 4w squared? 2w. What do you have to square to get 81y squared? 9y. And so the factored form is 2w plus 9y times 2w minus 9y. What about this? Is this a difference? Well, 50 is not a perfect square, neither is 2. But wait, I see something I can do. Do you see it? Remember the first thing we talked about? Greatest common factor. These two terms have a common factor of 2 that I can pull out. So I can write this as 2 times c squared minus 25, and then, oh look, c squared minus 25 is a difference of two squares. We can do that thing with it. So here we go. We leave the 2 here. It's still here. It's minding its own business, but it doesn't disappear. And then the c squared minus 25 breaks up into c plus 5 times c minus 5. Another pattern to watch out for is when you have a difference or a sum, this works with subtraction or addition, of two perfect cubes. Either one perfect cube minus another, like we have here, or one perfect cube plus another. So this rule tells you what to do with that. This is going to factor into two pieces. The first piece just looks like u minus v, with the part of u being played by x and the part of v being played by 2. And then the second factor has u squared plus uv, those two things multiplied together, plus v squared. So since the part of u is being played by x and the part of v is being played by 2, that gives us x minus 2 times x squared plus 2 times x plus 2 squared, which is 4. Now, if you want to see that this really works, check this by multiplying it back out. When you multiply two polynomials together, the x here gets multiplied by each of these three terms. So we get x cubed plus 2x squared plus 4x. And the minus 2 gets multiplied by each of these three terms. So you get minus 2x squared, minus 4x, minus 8. And do you see anything we can do to simplify this mess? Anything that combines? Well, the 2x squared minus 2x squared adds up to 0. The 4x minus 4x adds up to 0. The only thing that's left standing is the x cubed minus 8. Yeah. And what if we had almost the same thing but with a plus in the middle? That would be this formula. So the two factors look a lot like what we have here. The difference is instead of a minus here and here, we have a plus here and here. And then that means we're going to have a minus here to be able to have the stuff in the middle cancel out like it's supposed to. So it's x plus 2 times x squared minus 2x plus 4. And what about perfect square trinomials? Here, the pattern to look for is when you have a trinomial, so 3 terms, that starts and ends with perfect squares. So it has something squared at the beginning, something squared in the end, and then what you have in the middle should be 2 times the first thing times the second thing. So that's what we've got going on here. It starts with an x being squared. It ends with 64, which is 8 being squared. And then the thing we have in the middle is if you took that x and that 8 multiplied together and then multiplied it by 2, you'd have a 16x. So it does fit that pattern of the first thing squared minus 2 times the first thing times the second thing plus the second thing squared. And so that factors into just the first thing plus the second thing and then that whole quantity squared. X minus 8 squared. Notice when you have a minus here, you have a minus here. When you have a plus here, you have a plus here. And you always have to have a plus in front of that last term that's a perfect square. So here's another example. Can you see whether this fits that kind of a pattern? The term at the beginning is a perfect square. So it would be if you started with 10x and squared that. The thing at the end is a perfect square. If you started with 3 and squared that, that's 9. And if you multiply those two things together, a 10x times a 3, that would be 30x. And then the thing in the middle is 2 times that. It's two 30x's, so it's 60x. So it does fit the pattern. The part of u is played by 10x. The part of v is being played by 3. So this factors into those two things added together, because it's a plus, and then squared. 10x plus 3 squared. Last thing I'm going to talk about in this video is factoring by grouping. That's when you have 4 terms, and there's nothing that all 4 of them have in common. But if you kind of group them together into, okay, you've got the first 2 and then the last 2. And what do the first 2 have in common? Well, in the first 2, you can pull out a common x squared. X squared times 2x plus 1. And in these last 2, what they have in common is a minus 7. They're both minus and they have a 7 in common. So if I factor out negative 7, what's left is 2x plus a positive 1. And now look at this first thing and this second thing. They have a common factor of 2x plus 1. So you can pull that out and write this as x minus 7 times 2x plus 1. If you FOIL this back out, you get back to this. Okay, I'm going to end this video here and devote another video to maybe the big kind of factoring that you really have to get good at, and that's factoring trinomials. When you have a trinomial and you break it up into a product of 2 binomials. So that's its own separate video. See you then.